All right, everyone. Good morning. Hey, welcome to our period three, pre-calculus, here on a Tuesday. I'm trying to figure out right now, like if we ever met in the morning or if we've always been meeting in the afternoon. I don't remember. But again, this is our schedule. Welcome, everyone. All right. So to begin us, let's go ahead and today is the 12th, not January 11th. Today, here's our check-in. I'd like you to go ahead and think about something that you're grateful for today, and it could be about anything, definitely. Let me just make sure I have my power school ready for us. There we go. All right. So in the chat, either privately or publicly, share something that you are grateful for here today. All right, being healthy, grateful to be alive and healthy, of course. Waking up this morning, and grateful that we can be at school. Oh, yeah, for the in person people. I've been seeing some photos of that, like 8 people per classroom, I think. I've seen Miss Clark's pictures. Looks really fun. I'm grateful to be healthy, for family. All right, and getting some sleep. I'm grateful for being alive and my family, for health and family. Those are all very beautiful things to be grateful for today. Personally, for me, I guess today, what I'm grateful for is my legs. And the reason why I say that is so I'm trying to get into more movement here. It's not like really a New Year resolution. I don't really like doing like resolutions, but like it's an intention. I want to move around more, right? And so some of that involves getting on doing some walking in the morning or doing a little jog in the morning, and I'm lazy to do that sometimes. What I try to remind myself is, hey, you got legs, you're able to walk, you're able to use them. So that's something to be grateful for today. So that's what I'm choosing to be grateful for today. Just my legs. Grateful that my dog and I are alive and healthy. Yeah, that's very beautiful. Thank you so much, everybody. And feel free if you're still thinking about what you're grateful for to go ahead and share there again, either private or public. Let me go ahead and read who we have and who we're missing. Okay, so correct me if I'm wrong, and I'm sorry. It's so hard to do this quickly, but I think I'm missing Shema and I'm missing Kalia, Justin, Rainey, Ernesto, Jonathan, Ariana, and then lastly, Sakaya. Let me know if you are actually here, and I'm so I don't mark you absent. Let me do that one more time. So we're missing Shema, Kalia, Justin, Rainey, Ernesto, Jonathan, Ariana, and Sakaya. All right, and here we have some more gratitudes in the chat. I'm grateful to be one of the kids in physical class next week. Yay, that's so great. I know some are starting this week and some are starting next week. That's so great. I think seniors are starting next week, I believe. I'm grateful for my mom. I'm grateful to God for giving me an opportunity to live longer and keeping my family safe. Oh, I love that one. Yay. Thank you so much. So if anyone has any last burning gratitudes, make sure you put that in the chat. Ooh, grateful for my siblings. That's actually one of the things I also wrote. So every morning I like to kind of wake up and also write down some gratitudes. I put my sisters in there for sure. All right. And if you just came in, if you could answer the check-in question so I could kind of correct the attendance. And then we'll move on from there. All right. Let's go. Okay, thank you so much, y'all. So we got some stuff today. We got some group work today. So I just did some attendance check. We checked in with gratitudes. Today we're going to explore limits more. Specifically, we're going to try to explore like when a limit does not exist. So that's kind of new. Maybe it's something you heard about. And if you haven't learned about limits not existing, I'm gonna show you a clip from the Mean Girls movie. And let me also tell you all, I never seen Mean Girls, just so you know. I never seen that movie. I just know the clip just because it has limits in it. That's all. I've seen it, that clip so many times. So I'm going to show you that to kind of prepare us for our group work. Um, we're going to be doing something called annotative notes. I'm going to explain what that is. It's actually going to be a way for us to save time as we're looking at the lecture. So I'm going to let you know what that is once we hit there. I don't think we're going to hit the limit practice today, but that's all right because we still have other classes where we could dig deep into that. I did post asynchronous number 2. That one is due tonight. And just so y'all know, this should come with low stress. The reason for that is because it's a Khan Academy practice. What that means is when you're stuck, you could literally click on get the steps and the answers and it gives it to you. I definitely just want us to all at least try it. If you're completely lost, just use that help button and they'll help you with the answers and things like that. They'll even go step by step. You can write down like what your understanding is after looking at those. So this should be super accessible to y'all. Let me know if there's any questions about today's agenda or the asynchronous. And yes, I know some of you were messaging me that you turned in asynchronous 1 after I entered grades this morning. And I wanted to quickly enter that in, but I had small group support. So all my time was taken up in this morning with that. But don't worry, I'll get to it by the end of the day today to enter up those grades. Okay, awesome. Let's go on with it. Welcome, welcome. So, as a quick recap, y'all, last week we introduced limits talking about Benny and Bertha. They were walking and trying to meet up together. And in this example right here, Benny and Bertha, they don't meet up, right? But we also kind of connected what Benny and Bertha was doing, I don't know what's the correct grammar here, with the bottom limit notation. See if you go here. Again, I'm trying to not move my mouse too down because the slide bar gets in the way. So this is how you formally, yeah, there we go. It's popping up again. So down here at the bottom is how you kind of formally write how the bugs are moving with limit notation. One of the bugs, I think it was Bertha or Benny. I think that was Benny. No, that was Bertha down here. So Bertha was coming in from the left. And as you could see in the limit notation, you write a little minus sign after if it's coming in from the left. And because Benny was coming in from the right, notice how his limits notation has a plus right after the 3. I also want y'all to notice that they both ended up at different spots. Benny ended up at the height of 5, the y value of 5, and Bertha ended up at the y value of 1, and that's why they don't meet up. And just to kind of give you all like a formal way on how to describe what we were doing, these right here are called one-sided limits. Whenever you have like a left one, a right one, and you have plus minus, that's called a one-sided limit, just to kind of make sure that we have that as a word. And today we're going to talk about limits without looking at the one-sided. So this is a recap. You're not copying this down at all. This was from last week. Yes, that's correct. So right here, there's a clarification, but they both ended up on the Y3 line. So actually what you mean is they both ended up at the X value of 3. So you want to correct that. So right here, when I draw a vertical line, right where my mouse is going, that's at X equals 3 because this is the X axis. They both ended up on the correct X value, but their Y values were different and that's why they didn't meet up. Yes. Okay. Next recap is recall again, Benny and Bertha the bugs. Sometimes with some functions, they will meet up. So for example, here, if Bertha's here, Benny's here, and they start walking to go ahead and meet up, they will meet up. And as a reminder, Bertha here will not fall through this hole because she's too big to fall through it. So indeed, these bugs will meet up. And again, sometimes you're gonna have functions where they don't meet up. Depends on how the function is. Okay, y'all. So again, you're not copying down anything right now. We all have access and copy to these slides on Google Classroom. Let's go ahead and think about today's essential question before you all jump into your groups. Our essential question that I want you to think about is, when doesn't a limit exist? And I'm going to kind of preview this by showing you that clip from the Mean Girls movie. Like I said, I never seen this movie, but let me go ahead and play the clip for y'all.
Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist.
Our new state champions, the North Shore Mathletes.
All right, so there's the short clip. Like I said, I know the scene, I just haven't seen the movie. And the reason why I'm bringing up this scene is because it talks about limits not existing, and that's what we're going to actually learn today. So she's partially right. She said something about when the limit does not approach anything, it means the limit does not exist. And that's partially. We're going to kind of make sure that we get an exact definition of when a limit does not exist, today when we explore with our groups. All right. I hope that got you at least thinking about, limits here. Let's move on.
Contestants?
No, not again. Let's go on to the next thing. Okay. So right now we're going to be going into our groups, right? Your groups might be slightly different based if you did fill out that form, right? I kind of sent out a new one on Remind. So some of you filled out that form, some of you didn't. So I already pre-created the groups. Again, you could always let me know if there's any problems with that. Just text me and Remind personally if any issues, any group stuff like that. But what I'd like you to do right now is, before we jump into our groups, is I first want you to actually independently and individually take a look at what's going to be showing up as questions on your group Desmos exploration, so that you could first independently process this and then bring some ideas into your group when you all get started. So let me again put the directions there in the chat. We're going to be taking about 2 minutes to just independently process the questions. Feel free, if you'd like to, copy anything down, take any notes, up to you. It's not required though. There we go. I just typed out the directions for those of you who are more like, I'm the type that kind of sometimes visual instructions, verbal instructions don't stick with me. So I always want to make sure I put the instructions, I type them out. So there are the instructions. So right now, let's take 2 minutes. I know I don't have a little timer right here, but I'll do the timer on my phone. I'll see you all back in 2 minutes. Just take a look at the problems you and your group are going to be looking at today. All right, everyone. It's been about 2 minutes. I hope that you at least got to at least read through the questions, just process it before we jump into groups. So let me see what's next here. All right, good. So it looks like, so not yet. We're not doing this part yet. So it looks like it's time for me to set the group. So I have to stop my screen share. And let me see how it goes. I pre-assigned these. So if you are logged into your email, you're already in. So, oh, it looks like a good amount of you are logged into your email. So some groups are already set up. So I have to kind of just put in those who aren't yet logged in. Again, you want to make sure that you do not leave because you want your credit. I kind of heard some things coming out. I'm hoping that means they're logging in to get their laptop. All right. Let's go ahead and adjust the groups. Give me a second, everybody. I'm just missing a few people here. All right. And then just so you know, like if you're able to log into your email for next time, it just assigns you automatically. But I'm just going ahead and adjusting those who aren't done yet. All right, I'm gonna go ahead and open the room. So again, because we don't have everybody, there had to be some adjustments. Some groups only have one person, so I kind of had to add some. So here are the groups, and before you all go, yes, I'm gonna come in and check every group, make sure you all can share your screen. You do want to make sure one of you is logged onto a laptop, is able to share your screen. So again, if you don't have a laptop for some reason, you want to let your advisor know because we want to make sure everyone's set up so you can participate fully. Anyways, so once you're in their group, you're gonna go to Google Classroom to get the Desmos link. So go to Google Classroom as usual. Let me open up the rooms, everybody, and then we'll get started. Go ahead and join your group. Join your group. Let's go ahead and join our groups, everybody. All right, join your group. I'm gonna be checking in on groups. Amara, are you able to join your group? Hi, group. How's it going?
It's good.
Right. Who's screen sharing for us here today?
Guess I'm gonna do that.
I'll come back. Just hoping y'all can choose a screen share. I heard you a little bit, Jasmine, but I'm not sure. So Simia, Diva, let's know who's doing what. I'll be back.
Can you guys see it?
Yeah.
Okay. Okay, so who wants to be the recorder, the timekeeper, the team captain, and this one?
Okay, so where am I supposed to?
And then, hey, group, just so you know, I think this is a group. Okay, just so you know, I moved Angel in here because I had to readjust the groups in case if y'all need to have an extra role somewhere.
So like f of x equals 2, and then you put like the little minus. I think it's minus, right?
Yeah, f of x equals 2. And then, oh yeah, x equals.
Okay, we're not gonna have a team captain.
Wow, cool. Is this a phone sharing?
Yeah, my computer is dead, so I have to use my resources.
Wow, that's kind of cool. I didn't know you could do that. Awesome.
Write the limit statement for Benny's movement. Use the sketchable. What is this? Wait, is she still here? No, she's still not in here. The limit statement for Benny's movement.
Sorry for the noise in my background, but
Oh, wait, Mr. Donna, you're still in here?
yeah, still in
Oh,
here.
thank God. Okay, so Mr. Donna, for 2 Are we just supposed to basically write how the movement is from where they started to where they're at now?
Okay, so the limit statement is the thing where you write the limb and then like with the X and then the little arrow approaching. That's gonna be you want to try to write a limit statement that represents Benny's movement. I wonder if you could hear me. Your voice sounds a little bit robotic, but I understood your question. Does,
Okay.
does that yeah? And then Simia and Diva, are y'all okay?
I see what you're talking about.
Yeah. And then Simia and Diva, are y'all okay on this understanding? We doing all right?
Yeah, my background is just a little loud, so that's why I'm not really talking.
No problem. Yeah. Cool, cool. All right, awesome. Let me just pop on out. Let me know if y'all have any questions, or you can use the, I don't know if you're able to use the ask help button if there's any questions. But yeah, just try your best because afterward I'm gonna go over like the correct answers. So it's okay if it's wrong for now. Sorry, somebody talk. I mean, I don't know if anyone's referencing me. I hear a little bit of like a robotic voice somewhere. Uh-oh. I wonder if you could, I think, Jaleel, are you trying to type? Oh, okay, we're confused. Are you confused on the second part, number 2, where it says write the limit statement? First and second. No, the first one you all are pretty correct. Benny is moving and he's going to end up at the Y value of 2. I agree with number 1. You guys are good for number 1. Number 2 now is you're going to write the limit statement that represents Benny's movement. That means the same way that I was showing you guys with limb, like X approaching, and like having to be equal to something. So that's what y'all want to attempt. And it's okay to be wrong at it right now because afterward, I'm going to bring everyone together and we're going to talk about it. So it's just try it as an attempt. Number 1 looks good though. Well, we're going to see about whether it exists or not. You're going to see that question in the last slide of this activity.
Bro.
We have finished. We just finished.
Oh my gosh. Okay, y'all are finished?
Yeah.
Okay, cool. Let me check in on other groups. Good job, y'all.
All right. Fabiano, which one?
Well, you're asking if the limit does not exist for this one, right?
Yes, that's correct.
Okay. Well, one second. Just give me a minute. I think that the limit doesn't exist if it's going I think if it's not close to one another or like it's going different directions, I think.
Do the bugs meet up in this problem? Did Benny and Bertha meet up?
Yeah, because they got the same f of x value.
Oh, they got the same like output, like their limits were the same.
Yeah, it was
Oh,
at 2.
right. So the left hand limit is equal to the right hand limit. Is that correct? Because they both were equal to 2.
Yeah.
So if you look at that part where it says new definition, in that question, it says limits in mathematics exist when the right hand and left hand limits are equal. So would we say in this situation that it exists or not?
Oh, so it does exist.
It does because they meet.
Hmm.
So
Okay.
if they didn't meet, then that would probably mean that the limit doesn't exist, right?
Yeah, I think so. I think you got it. Awesome. Go ahead and yeah, just try to write out like a little explanation for that. And we're gonna check in afterward. Y'all are basically done after this question. I'm gonna give groups a little bit more time, so I'll be bringing everyone back in a little bit. Hey everybody, I'm just waiting for everyone to come back and then we'll start talking about this. I'm trying to just adjust this. I'm kind of standing, so it's a little bit difficult. So it usually takes a full minute for all groups to be back, bringing us all back so we could discuss and see. All right, let's see how much we have. I think we have everyone back now. So let me go ahead and get started with feedback and talking about how to do this and what big ideas. So like, does a limit exist or not for this situation? Does that relate to anything we saw in that clip at the beginning of class? So let's see. Okay, so first off, what I'm going to do is I'm going to go ahead and anonymize the names so that, I could give open feedback. So I'm going to hit anonymize, and as you can see, it changes your names. And I'm going to jump to what you all put here for number 5. And to see if y'all agree on where, for the first question, Benny ended up at. So good. So it looks like most groups are in agreement that Benny, as he's moving towards the right-hand side, and he starts at 1, 3, towards the right, so he's walking towards the right, he's going to end up at the y value of 2. And this one, Arthur's group give a coordinate point. That's awesome. And y'all are in agreement. Yeah, everyone said 2. Now, the part that actually shows the most difference is going to be the limit statement. So first off, take a look at the different limit statements that we got. We have first off, notice and wonder is that they look all very similar, except for the Niels one. But oh, Niels one, I think is trying to do a graph or something. I wonder. This one right here, I wonder about this one. But anyways, other than that, the only difference between the rest of the answers is that some of them have a minus after the 3. So I have 2 of them have a minus after the 3. And 1, 2, 3, 4 of you thinks the limit should have a plus after the 3. So let's see who's correct. So I'm going to go up here and I'm going to show you the correct answer, but kind of first annotating my graph. So as you all remember, I always kind of just go through my steps when I'm trying to find the limit. So step 1 is I like to draw a vertical line down towards the x value that we're interested in it. Because they're saying x equals 3, I'm going to go ahead and draw a vertical line down here. I'm going to do it like maybe a dotted line. So I first do that. And the reason why I do that is to kind of divide this graph into the left-hand side and the right-hand side. So that means this is my left and this is my right-hand side. Okay. Now, Benny is at the point 1, 3. So this must be Benny. This is like the closest bug that's at 1, 3. So this right here is going to be Benny. Okay. So remember, y'all, when you're writing your limit statements, what matters is where the bug or where it starts. So where the bug starts at. So Benny, as you can see, is clearly starting on the left-hand side. Yes, Benny is moving to the right. He's moving towards this direction. That's correct. But he's starting on the left-hand side. And when you're starting on the left-hand side, that means minus. So your correct limit statement for the 2 groups that wrote your minus, y'all were correct. So it should be a minus after the 3. So if you go down here, these 2 groups, so Gottfried's group and Camille's group, it should be a minus because Benny started on the left-hand side. It matters where they started, not where they're going towards. So that's the difference. Yeah, I was switched. So let me just make sure I put that. I'm gonna like make sure I write that down. So it's negative because that's where Benny started. That's the important point. Where did it start? And also, as you can see, 3 is right here, and all these values over here are less than 3. So of course, it's like, you know, it's minus. They're less than 3, so it kind of agrees with it. It should be minus from that side. So yes, this one was a minus after the 3, and that's okay if you got it wrong because it's a little tricky when they're saying to the right. So I understand how some of you might have put a plus there. But feel free to make some adjustments. Totally fine. All right, now we got 3 who believe so. Awesome. All right, let me know if anyone has any questions about this one right here before I jump into number 6. Maybe some of you want to quickly adjust number 6 if you made a little mistake on that part. But that's okay because we're still learning. Mistakes are expected. All right, if there's no questions on this one, let's go on. Number 6. So I love that I already did my annotations because I'm gonna still use the same ones. Let me just erase these up here. Okay, now it says Bernie, Bertha. Anyways, so Bertha starts at the point 5, 1. So this here must be Bertha. I should name a bug Bernie, yeah. Well, 5, 1's up here, but you know, this must be Bertha. And as you could see, Bertha is starting on the right side of the graph. Yes, she's moving towards the left, that's correct, but she is starting on the right-hand side. So therefore, the right is going to be a plus. And I could see that y'all are agreeing that we're going to be meeting up at the y value of 2 as well. So these two bugs are kind of going to end up at the same y value. Let's see what y'all put here for your limit representation. So again, it's clear that we have like a mix of pluses and minus. The correct one here is going to be plus because Bertha started on the right hand side of the graph. And yeah, most of you got pluses for this one. And like maybe about 2 minuses. 1 is almost there. I think 1's getting written down. Awesome. Feel free to complete that. All right, let me pause here and let's see if anyone has any questions so far before we go into that last part about whether or not the limit exists in this scenario. All right, y'all. Let's go on to that last question. So let me clear my screen, clear my drawings, and let's go on to it. So the last question, let's see what y'all said. So does the limit exist or not? I gave you like, first, before answering that questions, I asked you like, do the bugs meet up? Yes or no? And I want to take a look at the different. So remember, y'all, during the semester, we're focusing on our justification. So we want to make sure we put because, and you make connections to your graph or equation, whatever you have. So I like this. So yes, because they stop at the same y value. See that y value, making connections to the graph. For feedback, I'd push it to be like, well, what y value are they ended up at here? Let's see this one. This one looks well written out. So Jean's group, Benny and Bertha do end up meeting with each other because they have the same f of x value. That means y. When they travel, the x value of 3, which means they meet. So that one's kind of adding in that they're meeting at the x value of 3. So this one has more details to it. And yes, they're going to be meeting at the same points of 3, 2. And they end up having the same x and y. So all of these are good. This one I would push. Again, you want to add more details. It says yes because they stop on the y value, but what y value? And is it the same? You know, so I have like, I would push this to have more justification on it. You want to make connections to your graph, like what y value, what coordinate point, like we have up here in Arthur's group, anything like that. All right, so you all agree these bugs do meet up. Now we're jumping into whether or not the limit exists in this situation. So the review definition is one-sided limits can be found if you imagine a bug, walking to the left or to the right of an x value. The new definition that I'll be giving y'all today is limits do exist in math when the right and the left-hand limits are equal. As a group, does the limit exist? It says yes because both have the same answer. I would want like what's the answer? I wonder if there's more to this. No, I don't think so. The limit does not exist for this situation. And we have the limit does exist because the bugs meet up at the end and get the same output by Jean's group. We have yes, but we're missing a because. So we're missing the justification. And remember, that's going to be the push. Yes, this limit does exist because they end up meeting with each other. Yes, and then the limit does not exist. I would want to know about why the limit doesn't exist. So I'd like to know the reasoning for that. And again, I want to push you all to include justifications in your answers. Because you want to say, well, why? So this one here, Neil's group says the limit does not exist because they both end up at a value which is 2 and 3. So actually, y'all, let me go ahead and tell you all the answers. So some of you said that it exists, some of you said it does not. But y'all, when the bugs meet up, right, y'all agree that the bugs do meet up. When the bugs meet up, that means their left and right-hand limits are equal. And whenever the left and right-hand limits are equal, according to the definition, the limit does exist. The bugs are meeting up, which means their left and right-hand limits are equal. That means the limit exists. So the limit does exist for this situation. And we're gonna go ahead and synthesize this into our big idea slide. So again, make sure that y'all wrote your names, for credit, because I'll be entering in our Desmos credit. So, make sure that your facilitator wrote your names here. Thank you. Oops. Oh, these can't be blocked off, but that's okay. So just make sure that your name is on here so I could give credit. So this is usually where I go for credit. All right, I'm gonna go ahead and transition out of here so we could jump into our slides. So here's the new way that we're gonna be doing this, y'all. So notes. We're gonna be changing up how notes are done in this class. I know in the past I've been saying like, okay, copy it down. You're gonna either take a picture or you're going to like, upload it. Sometimes I've been collecting it. So we're gonna be changing this up. So the big ideas, I'm gonna go ahead and synthesize for you, like what are the big ideas of this activity? But actually, instead of copying these down on a piece of paper, I actually would like you to read and interact with them by just making a copy of the slide on Google Classroom. So if you go to our Google Classroom, right? I moved to the top our activity, but I'm gonna go ahead and move this to the top, our slides. And what's gonna be happening now is I'm gonna make a separate slide per day. So as you can see here, Q3, day 1, where I introduced one-sided limits, you'll click here and it's gonna take you to the slides. Q3, day 2, when we explore limits do not exist, that's today. So we're calling today, this is gonna be our day 2. This is the one you're gonna open and you're gonna make a copy of for yourself. And instead of you copying down notes, what you're gonna be doing is you're just gonna go on each slide and just make yourself little comments. Like you could just click a little comment box and just make yourself comments, and that's how you're gonna be taking your notes. The reason for this is because why make you copy down something that y'all already have access to and you could go back to, if that makes sense. And you could just interact with it by making comments and annotations. So again, you're gonna open this, make your own copy and follow along instead of, me waiting a minute or two on each slide, and we're gonna be better able to kind of just move through the content without, kind of getting caught up with copying it down. Let me know if anyone has any questions about that. It says for your credit, you'll instead be responding on a Padlet for checking questions. We won't have time to do that today. We're gonna save that for our next class. But for the future, if I do collect notes, it's gonna be you turning in your copy of the slides with your comments, and that's gonna be it for notes. Let's see, does anyone have any questions about this new way of notes? All right, so let me know, because then what that means for us is that I won't be pausing as long per slide. Again, because you're gonna have your own access to this, so I don't really have to pause as long. And even in college, it's gonna be like that. Like if a teacher has something already there for you, you're just gonna take little notes on that document, or you're gonna do what we're doing here, just open up a copy of it and just follow along and make comments as they come. So let's go on with it, y'all. So again, you're not copying this down. Let's go ahead and just look at the big ideas. The only time you're gonna have to actually need to write things down is when you're asked to do a problem, of course, but all right, y'all. So what are the big ideas from what we just did here, y'all? Number 1, first things first, you all agreed Benny and Bertha met up in this situation. They met up at the same Y value. So what that means when they meet up is that their left-hand side limit equaled the right-hand side limit. What I mean by equaling, it means they met up at the same Y value. Since they both equal 2, that means these two limits are equal to each other. And whenever that happens, and this is huge, y'all, pay attention to this next thing. When the left and right-hand limit are equal, we can write the limit without the plus or minus signs. Take a look. Sorry, take a look now. See that? Instead of writing a left-hand limit and a right-hand limit, because these two bugs meet up, that means the limit exists, and we could drop the plus and minus sign because the limit is going to approach 2 from both the left and the right-hand side. So we can drop that sign. So that's super important. Notice that. And now in our next class, we're going to go ahead and finish up talking about our big ideas from this group exploration. And I'll be telling you how to go about, like, following along with me in the notes. It's going to be like a Padlet, things like that. You will not be having to copy down notes anymore. Again, you're just copying the slide and making your own comments. And it's going to be, way better that way. What I'm going to do now is I'm going to go ahead and take us into our checkout, everybody. And an awesome job, by the way. All the groups I was in, it was really, really good. So our checkout, and that's why I put a note here. This is going to be where we stop for the day. What questions or clarifications or any understandings do you have about limits right now? Maybe based on this activity or anything like that. So any questions, clarifications, or understandings that you have about limits, go ahead and put that into the chat for our checkout. Let me give you some time to think of something too. Yes, that is hitting a humongous big idea. If the limits are equal, you don't use plus/minus sign. That's huge. That is a good takeaway from today's exploration. All right, let's keep them coming, y'all. We have the subscript is based on where the function starts. So subscript, I'm thinking about what subscript means in this scenario. The plus or minus depends on where they started. Yes, and that one came in privately. Oh, subscript. Okay, got it. So when the two bugs are on one line, they will always meet. So I love that one. I love that question that you just gave, because you're saying they're on a one line as if, the line is connected. So that means they will meet. And I would say the answer to that question is going to be yes for that question that was asked. Yeah, you're already making a visual connection to the graph, which is a really strong question. I wonder why, if the limits are equal, we don't need to use the plus or minus sign. That's a good question. The reason for that is because they're going to end up meeting from both sides to the same y value. And because they meet up at the same y value, when we drop the plus or minus, that means we know that it's coming in from both sides already without having to write two separate expressions. You could just write one expression. So it's one expression instead of two. That's a great wonder. Let's see for any last burning takeaways, questions, or clarifications. Again, privately or publicly. A lot of it is coming in privately, and that's okay. All right, so if we don't have any more burning questions or clarifications or understandings, we're gonna go ahead and head off into lunch. Y'all, it was a great class. Enjoy your lunch, everyone, and I'll see y'all soon. Bye, y'all. Everybody.
Bye.
Bye. Enjoy your day, enjoy your time. Yep, bye.